Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning. Today we will examine plate tectonics theory with emphasis on continental drift and the mechanisms that generate earthquakes. Plate tectonics is the unifying framework in geology that explains how the rigid lithosphere is divided into plates that move relative to one another on the weaker asthenosphere. Early ideas of continental drift proposed by Wegener suggested continents had moved, but modern plate tectonics explains the process by seafloor spreading at mid-ocean ridges, subduction at trenches, and transform fault motion. At divergent boundaries like the Mid-Atlantic Ridge, mantle upwelling produces new oceanic crust and causes plates to move apart at rates of a few centimeters per year, measurable with GPS. Convergent boundaries operate in two main modes. Where oceanic crust meets oceanic crust or continental crust, the denser oceanic plate tends to sink beneath the less dense plate, forming a subduction zone, a deep ocean trench, and often a volcanic arc or mountain range. An example of continental collision is the Himalayan orogeny, where the Indian plate collided with the Eurasian plate. That collision did not create subduction at the plate interface, but instead uplifted vast mountain ranges. Transform boundaries, such as the San Andreas Fault, are characterized by lateral displacement. There is little creation or destruction of crust, but stress accumulation and sudden slip produce frequent shallow earthquakes. When we discuss earthquake generation, we must consider the elastic rebound model. Stress accumulates along a locked fault until strain exceeds friction. Then the fault slips and stored elastic energy is released as seismic waves. Depth of earthquakes varies with plate tectonic setting. Shallow earthquakes occur at divergent and transform boundaries. Deep earthquakes occur in subduction zones because the sinking slab can remain brittle to great depths. For instance, the 2011 Tohoku earthquake was a megathrust event at a subduction zone. The Pacific plate subducting beneath the adjacent plate generated a very large rupture and a devastating tsunami. We also observe patterns of seismicity around the Pacific Ring of Fire, where subduction zones, volcanic arcs, and frequent earthquakes mark plate boundaries. Mechanisms driving plate motion include mantle convection, ridge push at spreading centers, and slab pull, where a dense sinking slab drags the trailing plate. These forces together explain observed plate velocities. Finally, evidence for plate tectonics includes matching continental margins, paleomagnetic stripes on the ocean floor, distribution of fossils and rock types across continents, and modern geodatic measurements. Understanding plate tectonics is essential because it links continental drift and earthquake processes and helps us assess seismic hazard and the distribution of mountain belts and ocean basins.
Listen again to part of the lecture. Then, answer the question.
Deep earthquakes occur in subduction zones because the sinking slab can remain brittle to great depths.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.